Awesome. Our last type are going to be rational inequalities. Now we go at these the same way we do with the quadratic, where we have to get our critical points. All right, so check this out. If I have 5 over x plus 4 is greater than or equal to 1, the first step is the same. Find your critical points. I'm just going to put CP on this one for critical points since we wrote it out in the previous video. Okay, now here's the deal. Whenever you find your critical points, you need to set your equation equal to 0. So in order to set this equation equal to 0, I need to subtract 1 from both sides. Now when you subtract 1 with a fraction, you need to get a common denominator. So whenever I subtract 1 from the left side, I actually end up with 5 over x plus 4 minus, now to get a common denominator of x plus 4, you convert 1 into x plus 4s because that's a common denominator. Whatever you do to the bottom, you have to do to the top. This is now equal to 0. So now we have a common denominator. Make sure when you are subtracting that you distribute the negative sign to both terms. So we want a single rational expression. That's our goal here. So with our single rational expression, we now have a negative x plus 1 over x plus 4 is now equal to 0. That's what we want to look at here. Oops, I'm jumping the gun here. This is greater than or equal to 0. We just want to get that set up first, and then we'll set each one equal to 0 to get our critical points. So we use our inequality first. Now do you see how I get that negative x plus 1? In my numerator, I have a 5 and a negative 4 are like terms. So 5 and negative 4 give me that positive 1. And then I just take my negative x because it doesn't have any like terms inputted there. Good, I wanted to make sure you didn't miss that point of it. Cool. Now, when we set up our critical points, we're going to set the numerator equal to 0 and the denominator equal to 0 to find our critical points. So for the bottom, I get x is equal to a positive 1 because you add x to both sides, and then you subtract the 4, so x is equal to a negative 4. Then you use that for your number line. And then the same thing happens with this. Step 2 is do your number line and check 0. So basically, for the quadratics and the rational inequalities, you're doing the same process. The only difference with these two is how do you get your critical points. With the quadratics, you factor. With the rational, you set the numerator and the denominator both equal to 0. So it's no big deal. You got this thing. So I'm going to put my values, a negative 4 and a 1, and remember the same thing applies. You're either going to shade to the outside or to the inside. Those are always your only two options. When you look at my math lab for these problems, it's going to give you a different approach. It's just more time consuming. Yes, it's mathematically correct, but if we know you can only shade to the outside or inside, then let's just shade to the outside or inside. Go through this and check 0 and see which way which way you're shading. Remember to check 0 in the original. So if I'm checking my 0, I have, so let's come off here to the side, check 0, that says I have 5 over 0 plus 4 is greater than or equal to 1. So is 5/4 greater than or equal to 1? Yes, it is. That's an improper fraction. You actually have 1 and 1/4, so that's obviously bigger. So if where 0 is makes my statement true, then that is where we're going to shade. Now here's the kicker whenever it comes to this problem. Notice the x plus 4 is in the denominator. So because this is in the denominator, that has to be a parenthesis. Because remember, if you can't have a 0 in the denominator, and negative 4 will make a 0 in the denominator. So on negative 4 is a parenthesis, but on the 1, that's going to be a bracket because my symbol is an or equal to symbol. So I have a parenthesis in the denominator and a bracket for the numerator. So that's a little different than our quadratics that you're looking at, but still doable. So whenever you have the rational inequalities, remember parenthesis for the denominator, and then if it was just an equal, if it was not an equal to sign, then you would have your parenthesis. Good. So the symbol for the numerator goes with the symbol in the problem. The denominator, always parenthesis. There we go. Okay, let's try one more of these guys. Here's example 9. We have a 2x minus 1 over 3x plus 4, and that's going to be less than 5. Cool. Now the same thing applies here where we need to find our critical points. So we're going to go ahead and subtract 5. Now check this out. We are going to subtract 5, but you still need a common denominator. So you have your 2x minus 1 over 3x plus 4, but to get a common denominator, I have a 3x plus 4 and a 5 times a 3x plus 4. You see what I'm getting at there? So you multiply the top and the bottom of 5 by the 3x plus 4. We all right with that? Okay, if you're struggling with this, make sure you're asking me in class. That's the beauty of the flipped. So let's keep going. So we now have our common denominator here of 3x plus 4, which is awesome. Now I'm going to take this negative 5 and distribute it. So in my numerator, I have 2x minus 1 and a negative 15x minus 20. Cool. Now combine our like terms. So I have a 2x and a negative 15x. So you get a negative 13x. You have a negative 1 and a negative 20. So subtract that 21. And you still have 3x plus 4 in the denominator. So now we have our rational equation set up. From here, we can do our critical points. Our critical points are going to be a negative 13x minus 21 equals 0. So that gives me a negative 13x is equal to a positive 21. Oops, I forgot my x. Divide both sides by a negative 13, and I get a negative 21/13. There's my first critical point. My second critical point is at 3x plus 4 equals 0. And this one's a little bit easier with our numbers, so I'm going to go straight to the answer of negative 4/3. So I have a critical point at negative 21/13 and at negative 4/3. Cool. All right, now when we put these values on our number line, we have negative 21/13 and a negative 4/3. Notice where 0 is. It's over here to the right. Okay, typically when we're finding 0, it's been in the middle, so we know whether we shade to the middle or the outside. The concept still applies. We're still going to check 0 because that's the easy thing to do. However, because I'm out of room on this slide, let's move it over to the next one. Okay, let's go ahead and pick this problem up from here. So we know we have the negative 21/3 was in the numerator. The negative 4/3 was in the denominator. The beauty of this problem is the fact that all I have is a less than symbol. So I know regardless, both of these are just going to have parentheses on it. Okay, let's check that 0. So if we're going to check 0, we now come up with 2 times 0 minus 1 over 3 times 0 plus 4 is less than 5. So is negative 1/4 less than 5? Heck yes it is. That means where 0 is shaded. Now remember, you can either shade to the outsides or the inside. So if I'm shading to the outside on the right, you also have to shade to the outside on the left, because it's either an outside or an inside situation. Because it's a less than symbol, both of these signs are parentheses. And again, I'm jumping over the middle, so when you write your interval notation, you're going to go from negative infinity to negative 21/13, parenthesis, union with parenthesis, a negative 4/3 to infinity. Awesome. Good job. That's going to take care of our rational inequalities.